We're just going to give it a minute or two to let people continue to join, then we'll get started. Hello, everyone. Thank you so much for being here. On behalf of the Environmental Finance Center Network, welcome to today's webinar on anti-degradation, the most misunderstood water quality standard. My name is Owen Volk from the Syracuse University Environmental Finance Center. Before we begin, we are going to go over a few logistics and then we can get started. During the webinar today, everyone will be kept on mute to ensure audio quality. If you have a question, please type it into the GoToWebinar question dialog box anytime throughout the session. We will be saving your questions for a facilitated Q&A session at the end of the presentation. After the webinar, you will receive a follow-up email that includes a link to the recording and other information that you may need. You can also download the slides from today in the Handouts tab in your GoToWebinar control panel. This webinar has not been submitted for pre-approval of continuing education credits, but eligible attendees will receive a certificate of attendance for their personal record. To receive a certificate for the session, you must attend for the entire session and register and attend individually using your real name and unique email address. Certificates will be sent via email within 30 days of the webinar date. If you have questions or need assistance, please contact smallsystems@syr.edu. Now, for a little bit about us. The Environmental Finance Center Network provides training and technical assistance to small water and wastewater systems in all U.S. states and territories through our building technical, managerial, and finance capacity programs. If your community or utility needs assistance with drinking water or wastewater system management, please feel free to contact us through our request form, which I will be sharing shortly in the chat. One of the many ways EFCN can support your community or utility is through our free funding application support. Struggling with an infrastructure funding application? Falling short on project funding? Not sure where to start? EFCN is here to help. Submit a request through the link in the chat to receive tailored support based on your project needs. And on that note, we can get started. I would like to introduce our presenter for today, Mike Tate, Project Associate at the Environmental Finance Center at Wichita State University. Welcome, Mike. I will go ahead and hand it over to you.
Okay, thanks. Okay, are my slides showing? Nope, show my screen. There we go. And okay, yeah, I wonder, are my slides showing?
We are currently looking at the PowerPoint view. We don't have the actual PowerPoint running.
I'm seeing it on mine. Let's see here. About that.
There we go. Yep.
Okay, sorry about that, guys. Well, just a little bit about myself. My name's Mike Tate. I'm a licensed engineer in Kansas. I spent 30 years with the Kansas Department of Health and Environment, almost entirely in clean water and drinking water. When I retired, I was the director of the Bureau of Water at Kansas Department of Health and Environment. And after that, I spent about 6 years at EPA and retired from that. And now I do some work for Wichita State as well as my own consulting firm. So I've been around the clean water business, if you added all of that up, close to 40 years now. And so what I want to talk about today is anti-degradation. It's probably going to be a little drier, maybe a little more in the weeds than a lot of topics that you hear, but it's one that I think is important. And I also think it's really misunderstood. That's the title of the presentation. And so it reminded me of lyrics from a song by the Animals back in the 60s. It says, "I'm just a soul whose intentions are good. Lord, please don't let me be misunderstood." So if you're of a certain age, you probably have heard that before. If not, go to Spotify, YouTube, and find it and get that. So before we get started, I'm going to have Owen run a couple of polls. I want to kind of figure out what your background is, who we're talking to, and kind of your maybe level of knowledge of what anti-degradation is. So Owen, if you want to go ahead and run it.
Yep, first poll is up. Give it about a minute, and then we'll go through the responses and run the next one. Okay, so we got most responses in, so I'm going to close this one out. So the responses for the first poll, about 15% are local government, 65% are state and federal government, 1% is industry, 11% are consulting, and 6% are other. So we will roll on to the next one. Okay, another 10 seconds. Okay, so the results for this next one asking about their knowledge on anti-degradation. 5% said excellent, that they've experienced anti-degradation application. 32% said good, they've received education but not experienced its application. 40% said they've heard the term, are not sure how it's applied, and 23% said they have minimal knowledge.
All right, sounds good. Okay, well, let's get going then. And got to give a little bit of a history on anti-degradation first before we get into exactly what it is and how it's applied. But why is it the most misunderstood part of the standards? I think, it's because it is a water quality standard, but where it usually hits people is when it gets implemented through their NPDES permit. And so they see it as an NPDES permitting type of thing most of the time, while it really is a water quality standard. And the term anti-degradation, and this kind of frustrated me back in the day when I first started getting into this. Oops, sorry about that. You couldn't find it in the Clean Water Act, the big 1972 Clean Water Act that came up and had the NPDES program and all of the stuff that talked about impaired water and water quality standards. And it wasn't ever amended into the act until about 1987, and even then wasn't real clear. The concept, though, existed back in this Water Quality Act of 1965, and that's when kind of Department of Interior, EPA didn't exist at that time. So the Department of Interior was kind of over these water quality issues in the nation. And they referred to it as a policy of non-degradation of interstate waters. And so that interstate waters term is in there, which you can imagine, you know, why it is. I live in Kansas, Kansas City, Kansas, and Kansas City, Missouri share a border, share a river. Basically saying, well, just Kansas, because you're upstream, you shouldn't just dump all your waste in right at the border and impair waters in Missouri. So kind of that concept of fairness in terms of not degrading somebody else's water. But it did say, as long as you maintain the existing quality of the water, you know, you could degrade it some if it was, in their term then, justifiable. So the anti-degradation rules then got first adopted in 1983. So you can see 11 years after the Clean Water Act. So, you know, this had been in place, and then we finally got regulations on it. And the regulations were justified by the fact that it supported the goals of the Clean Water Act. And if you've ever had any courses or studied the Clean Water Act, you know, right up in the first few sentences of it, it says the goal is to restore, maintain chemical, physical, and biological integrity of the nation's water. So they're saying this concept of anti-degradation and not degrading any more than you have to is kind of restoring and maintaining the quality of waters. The thing is, though, it was a really short regulation. And if any of you have ever looked in the Code of Federal Regulations, a little book that comes out, it probably wasn't more than 2 columns on a page that described the whole rule. And so it was sort of vague as to really what it meant and how to apply it in a lot of people's minds. And that's probably why EPA eventually came up with over 200 guidance documents to try to explain this little short regulation. And so in 2010, EPA was proposing an update to their water quality standards regulations, and there were about 6 things they were focusing on. And anti-degradation was one of those. And so they put out a proposed regulation for comment. And I was with the state of Kansas at the time, and we and many other states kind of objected to some of the language that was in there, particularly on anti-degradation. The main being that it said that if you had to use the least degrading alternative to discharge into one of these high quality waters. And that, we thought, that's not so great. You know, you could have somebody spending every last dime they had in their community and maybe only improve water quality just a little bit. It's not a very good use of money. So we commented on that. And then more kind of techie government thing was that some states said they didn't want to have to adopt what was called guidance into regulation. You know, their state said you don't put guidance in regulation, so let us have a guidance document freestanding. I've commented on a lot of regulations, and I've never really been called or asked about them, but this time around, after EPA put that out and got the comments back, the Office of Management and Budget has to meet with the states. And if you're not aware, all federal regulations have to go through the Office of Management and Budget, and they kind of decide what can and what can't be adopted based on comments. And so they asked to meet with the states because of all those comments that came in on the regulation. So 4 states met with OMB, and I happen to represent one of those 4 states that made our comments. And really quite surprising to us, the outcome of the whole thing was that OMB didn't allow EPA to finalize that regulation along with the other standards they had proposed, and said they needed to work with the states on that. So EPA contracted with WEF, the Water Environment Federation, to hold some facilitated discussions between the states and EPA on these various topics and why states had issue with it and how they might be worked out. So after about 3 years of that, a conceptual draft rule was put out by the states and EPA. And again, surprise to me, OMB remembered that, you know, states had kind of had issues with it before, so they wouldn't allow it to be released as a proposed rule without sign off by the states. And so 2 state representatives, with me being one, met with OMB, and we acknowledged that, yeah, we had worked with EPA on this. We were good with the language as it was proposed. And so after that, the rule was put out for comment. And then in August of 15, the rule was adopted, and it became effective then October of 2015. So we're a decade into this now that we've had those new anti-deg rules. So you can read for yourself what the other items were that were in that package. There were 6 altogether, but the anti-degradation provisions was one of those. And I would say it was probably one of the most contentious and most commented on. Because if you're unaware, EPA and really all states have to do a response to comments, I think, when they put out a rule. So EPA did their response to comments as they called them essays. And so they had 14 essays that addressed all the comments that came in, 460 pages total. And anti-degradation had 151 of those pages. So you can see it was about a third. There were 6 things, and anti-degradation took up about a third of the comments. So it was really important to people, you know, to get an understanding of it and to be comfortable with it. And what it did, it added a couple of key elements that weren't there in the previous, you know, kind of very basic rule. And that was an alternatives analysis. And the alternatives analysis said you look at different alternatives to treatment that might be lesser degrading, and that is what came out of it. And that was the states coming up where they said, we don't want this least degrading. We could be wasting a lot of money with that, but we want to look at lesser degrading alternatives. It also required the implementation procedures for your anti-degradation rule, but it didn't require it to be adopted in regulation, which was another state issue. It simply said now you had to have it, but it had to have public involvement in its development. You couldn't just develop it in a vacuum. If you were a state, you had to go and allow the public to comment on it and help shape that implementation procedure. So a lot of people tell you, if you've ever had any training, you know, Clean Water Act, water quality standards, they'll refer to the water quality standards as a 3-legged stool. And the 3 legs on the stool are designated uses, water quality criteria, and anti-degradation. Pretty much everybody was familiar with the other 2, not so much with the anti-degradation. And so designated uses, if you're not familiar with what that is, simply, you know, as the states, as you develop your water quality standards, you take water bodies, could be a river, a segment of a river, what have you, and you assign the designated uses to those waters that you think they should protect. And there's a couple that, you know, through the federal law, you have to have, which is recreation and aquatic life support. And then states come up with a lot of different ones, like drinking water supply. In Kansas, we have a lot of agriculture, so we have an irrigation use. We have a livestock watering use in Kansas. So you can have all of those. And then based on those uses that you specify, you then come up with water quality criteria. And I think when a lot of people talk about standards, they really are probably meaning water quality criteria. And those criteria define those benchmarks for, you know, kind of how clean the water should be. And those kind of come out 2 different ways. You can have a numeric criteria. You know, for example, one you'll see in a lot of states, dissolved oxygen, and dissolved oxygen has to equal 5 milligrams per liter. And that 5 milligrams per liter tends to support then the aquatic life use. You then can come up with numeric criteria for all those different uses. And sometimes it gets kind of interesting. It's like Kansas, I told you we had a livestock watering use, and we have a criterion for boron because that is significantly affects cattle. Doesn't really do much for drinking water or recreation or anything else. So, but we do it for cattle. And so then when your permit gets developed, people are developing permit limits based on the criteria, the most stringent criteria for whichever uses you have applied to that body. There's also narrative criteria, narrative water quality criteria, and you see those a lot. People, you'll hear them called the free-froms a lot of times, like surface waters shall be free of deposits of sludge or fine solids attributable to an artificial source of pollution. You'll see that for color, maybe odor, lots of things there. So those are the criteria. And then you got down to the anti-deg, which I will say a lot of people either didn't pay attention to or they didn't pay attention to it because they didn't understand it, really got defined better in this update rule. And it's really what's called a framework for maintaining and protecting water quality that you've already achieved. Think of the concept. Okay, we went to a whole lot of water effort to do non-point source controls, to do point source controls through NPDES permits. We got the water pretty clean. Let's not slip backwards. And that's really what that is doing. And it also then again requires that you have a procedure. You tell the public how you're going to implement that anti-degradation policy, and it has to have the public involvement. I think a pretty good summary of anti-degradation came out in EPA's 1995 economic guidance for water quality standards, and says it's not to be looked at as no growth. We're not trying to say you can't degrade any water anywhere, and so essentially you can't grow. They say right up front, it's not what that it is, but that it allows the public the opportunity to make decisions, to make comment on these important environmental actions that might degrade water quality. And so what it then directs the state to do, it says where you intend to provide for development, you can lower water quality in these high quality waters. These are all terms we're going to get to later as to how they're defined, if it's necessary to accommodate important economic, and it's an or, not an and, but an or social development. So essentially, if a state believes it's important for the local economy, local community to put in a new or expanded wastewater treatment plant, they can propose to do that and lower the quality of the water somewhat, but it has to go through public comment process. The public can take further action than if they're aggrieved by whatever the state decides. So anti-degradation, we're talking about in terms of waters. We kind of define the tiers of waters as they're called. And the federal regulation has 3 tiers of waters, 1, 2, and 3. I'll talk a little bit later about some states have created a different tier of water in their standards and try to explain why that is. But we think of tier 3, and that's what's called outstanding national resource waters. And those tend to happen because they're high quality waters or they're waters of exceptional significance. And that exceptional significance can be ecological or recreational. Now, when you have these waters that are deemed outstanding national resource waters, you can add no additional pollutant, okay? Essentially, there aren't going to be any additional discharges to these waters if that's the case. And that can be pretty significant for a state. You know, you want to make sure that, you know, there would never be any need to have a discharge for anything. And so that can be for high quality waters. I've seen some nice high mountain streams that are very high quality that for recreational purposes, States like to keep those clean and say, no discharges into them. But a lot of times what it is it's this ecological significance. For instance, in Kansas, the waters we have as outstanding national resource waters are like, one of them I'll give you an example is called the Quivira Wildlife Area. And it's really the Quivira Salt Marsh. So Kansas, if you didn't know, used to be an ocean at one point in time. So you get a lot of those kind of deposits that can lead to very salty water emanating there. So these salt marshes have high chloride. You can think of it being a marsh, growing plants, they're falling over, they're releasing nitrogen. The quality of the water really isn't great. It's not something you'd say, wow, that's really outstanding. But those wetlands are in the national flyway, and you have millions and millions of birds every year that use those as they're migrating from north to south or south to north. So they have great ecological significance, and you're not going to want to ruin those with any kind of discharge going into them. So the whole point to make here is that while a lot of times people think of tier 3 as being this really super high quality water, most instances I've seen, it's more to protect this ecological source. It may not be the greatest quality in terms of the numeric values, but it does have a very important use. And then tier 2, which is where we're going to be focusing on most of today, that's where water quality criteria are exceeded. The water is much cleaner than it needs to be to meet those uses that you assign, say recreation or aquatic life support. And then tier 1 is it just meets the water quality standards. So in tier 2, again, we get into this, you can have the lowering of quality if it's needed to support economic or social development. States then created what a lot of them call a tier 2.5. This isn't in federal rule, but a lot of states do it. And it's because a lot realize that if you label a water an outstanding national resource water, a tier 3, and there's never going to be any discharge into it again, who knows what might crop up in the future? Is there a billion-dollar business that shows up and needs to discharge in that location or wants to discharge in that location, and you basically said, no, you can't do it. So this tier 2.5 that most states created, again, it in federal regulation, but what it does is it kind of makes it something between a tier 3 and a tier 2. It says, we know you're good quality water, it's high quality water, and we really don't want to do anything with it, but if something exceptional comes along, then we may require you to go above and beyond in order to discharge into that water. So it gives you something in between this tier 2 and tier 3. So if you look at it in terms of my little graph here, says increasing water quality, as you go up the tiers. Sometimes why there's the question mark, you do in tier 3, but as I mentioned, a lot of times it may be a national park or a wildlife refuge where the quality isn't great, but it's important ecologically. Tier 2, we'll do this analysis of alternatives to see if there's less degrading alternatives. And if there are, we choose, and there's one that's practical, we choose it. So, and then tier 1 is just kind of meets water quality, which I've always found interesting. We treat it like a single point, like it's some line in the sand, whereas these other tiers have some kind of range associated with them. So that's why I come up and say, if you've ever really dealt with water quality, it doesn't stay right at one value. It goes up and down, could maybe go up above that criteria and down below. Probably ought to be some kind of range. But regardless of that, our focus is really today is going to be on this tier 2. Okay, these high quality waters. And when you have to do this anti-degradation analysis and ID these lesser degrading alternatives. So what is tier 2? Well, for permitting purposes, NPDES permitting purposes, it really comes into play for new or expanded discharges. It really says if there's a new discharge or you're expanding an existing discharge and it's a high quality water, at tier 2 water, then we need to look and see if there are lesser degrading alternatives that you can choose. If it's a tier 1 water, it really didn't come into play. But that's, you know, when you do it in these tier 2 waters that are high quality, you know, that are better quality that needed to meet their designated uses. Now, how's high quality defined? Ooh, boy, it's all over the board. But there's basically 2 ways of doing it. It's called water body by water body analysis, and that's where each water body or segment of a water body, you can go to some kind of register that shows you which ones are tier 1, which are tier 2, and which are tier 3. And it's really kind of regardless of pollutant. It's just the whole water body is in one of those tiers. The other one is called pollutant by pollutant analysis, and that's where you evaluate whether water quality is exceeded, you know, better than it needs to be for each pollutant in a water body. And I would argue that there's probably at least one pollutant somewhere that's better than the water quality criterion in every water body. So there's going to be something that'll be high quality, in my opinion, in almost every water body. And that's what I say here. It means that a water body then could be high quality for ammonia. You know, it's much better than the ammonia criteria. But say you've got high bacteria, E. coli, or zinc, it might not exceed those. So that same water body could be tier 2 for ammonia and tier 1 for E. coli or zinc. So that's it's sometimes hard to wrap your head around, but that's the way it works, and most states do it. And why do they do it? Well, only a couple of them do this water body by water body, and it really simplifies life. And so you've got to be asking then, why do only a couple of states do it? Why do they publish their tiers? And it's really because the rule says you've got to look back at what the existing uses of the waters were when you define your tiers of water, the 1, 2, 3. Existing use is then defined as the uses as they existed on November 28th of 1975, okay? So remember, this rule, first rule, didn't come out till 1983. So a lot of states figured out too late how to go back in time and try to assess where they were at in 1975. There's a couple of states who did, and I'm envious of them, but not many were able to do that. States have also tried sometimes to define non-high quality waters. I thought, well, that'd be an easy way around it. If they have a TMDL, or total maximum daily load, which says they're impaired, then they say, well, that can't be a high quality water. It's got to be this tier 1 water or something else. Well, the courts have said no many times. There have been different ways people have tried to go about it. And I agree with the courts, because, you know, if it has a TMDL, it was a tier 1 or could have been a tier 2, even a tier 3 water, but for some reason it got polluted enough that it got impaired. And so the whole goal of the TMDL is to get it back in one of those higher tiers of waters. So you can't just get out of it by saying everything that's got a TMDL automatically becomes tier 1. So if you look, this is Oklahoma's, just a page out of their register that I talked about, where they identify the different streams and give them their numbered water body. And on this limitations is really their tiers of waters. They got high quality water, which would be a tier 2. They call it an outstanding resource water, which is a tier 3. And then they have this sensitive water supply that they've created out there, which I'd call maybe kind of a tier 2.5. They apply it more like a tier 3, but That's how they go about it. So it's real nice. If you're going to discharge into a river or a certain water body, you go to this list, you look, well, what is it? And if it's blank, it's a tier 1 water. Unfortunately, like I say, only a couple of states really do that. The rest do this pollutant by pollutant. Well, there's well over 120 pollutants that have had water quality criteria documents put out that people may or may not have adopted in their state water quality standards, but there's a bunch of them. And you don't really have to look at each one of those. You just need to get an agreement with the regulator up front on what are the pollutants of concern, the POCs. And those are the pollutants that are considered to be at levels that make the water high quality, and they are potentially in the wastewater effluent of that discharger that's going to discharge. So then it's the POCs you evaluate for alternative treatment. And after you identify those, hopefully the regulator can give you the background, what they consider the background concentrations of those pollutants in the water body, and whether or not one of these total maximum daily loads exist. So what I'm going to do, the next 2 slides, I'm going to give you what I see as my 11-step process for doing an anti-degradation analysis, and then we'll go into each one more in depth after that. So first, determine whether the anti-deg applies to your discharge. Again, new or expanded discharge, high quality water. Determine if it's important. Remember, we have that requirement. The state has to say it's important for development, to support social or economic development. And then we determine the pollutants of concern, and again, in coordination with the regulator. I got a horror story to tell you later about that. And concurrently, hopefully the regulator can provide you kind of a dummy permit limits that they'd say, well, if we just did this, not considering it a tier 2 water, here's what your permit limits would be. You then develop a high level design and cost to meet those permit limits they would give you. And that's what's called the base case. That's the base case you build, and that would be without looking at any alternatives. But then you're to develop and identify and develop lesser degrading alternatives and the costs associated with those. And you identify any lesser degrading alternatives that are practicable, and any practicable alternatives, if there is, you'd use one. If there aren't, you go with the base case. I'm going to warn you now, detour ahead. I just like the word practicable, but it's what we got to deal with. It's in a lot of federal rules, and it's specifically defined in this rule. So when we get to that point on item 6, we're going to talk a whole lot about practicability. Afterwards, you get all that done, you submit the anti-degradation analysis to the regulator. If you've been working with them up front, agreed on the POCs and all of that, shouldn't be a lot of questions, but they may ask you to modify a little bit as needed. The regulator then, as they public notice the draft permit for the facility, also state that there's an anti-degradation analysis available, and the public can request that and comment on that. And then based on public comment, the regulator is going to issue the permit as they proposed it. They're going to modify it, or they're going to deny it. So let's get into detail of an anti-degradation analysis. First off, again, does it apply to your discharge? Well, are you a new or expanded discharge? If you're just renewing your permit, you shouldn't have to do it. You know, it should have been probably, your limits should have been based on your design flow. And if you haven't reached your design flow and proposing to expand, shouldn't probably need to do it. The second part of that is it in a tier 2 water. And as I've said before, I think there's probably something that's tier 2 for some pollutant in just about every water body. So I'd tell most people probably plan on doing it. Then you have to say, well, is the discharge important? And that's really a call for the state, but whoever's doing the anti-degradation analysis probably ought to have those discussions with the states. up front as to how they propose to go about doing that. And remember, it's to support, economic or social development. Again, I say that, yeah, if you're going to do any kind of expanded discharge, it's probably going to degrade in some form or fashion. Even if you keep the same concentration of a pollutant, you're putting out more mass of that pollutant, etc. Temperature can change, and temperature is a pollutant. So really, I think you probably ought to plan on doing one. And so that first step is, you got to show why it's important to accommodate economic development or social development. And I'll point my finger at myself. As a general rule, engineers hate to think of the social aspects of it, like to work with numbers and do things, but it's really not too difficult, I don't think, to justify it. And I'll show you how I would do that later. So important social development, you can be improving water quality treatment. Even if you may put out some of an additional pollutant, most of the time on a new plant, if you're replacing a 20, 30-year-old plant today, you're going to be probably putting out less BOD, less solids. I'd say ammonia, all those things may lead to actually better water quality from your plant. Socially too, it can allow the town to grow. If the community has reached its size that the treatment plants at capacity, community growth can provide more tax dollars, and those tax dollars can be used to improve the quality of life, etc., in the community. As far as the economic development, towns may want to provide more capacity for industry to help grow their local economy, provide for more population growth, which can expand their tax base and allow them to do more things, provide better services, newer expanded businesses that could be attracted in, can provide jobs, all these things, you can put in. And I'll say there probably is somewhere out there one that's been turned down for not being able to show that it was important. But I haven't seen one. There's generally a reason cities are and industries are proposing a discharge or proposing expanding a discharge. The one thing to remember, though, and I said it earlier, is that even though it might be important to expand that discharge, you can't ever say, well, I'll let it impair water quality. I'll drop the water quality criteria in the stream below what the regulated values are. You can't do that. You can't impair a water just because a discharge would be important. You've got to at least meet those minimum water quality criteria and not impair the designated uses. So next step, in conjunction with the regulator, you're going to identify pollutants of concern. Talked about that, I think, enough. And at the same time, I would seek, like these dummy or mock permit limits from the regulator as to how they would permit it if you aren't going into a high quality water. And then you would develop a wastewater treatment plant concept that would meet those limits and call that the base case. And the base case, you could say, may just meet water quality standards and it maintains the existing uses of the water. And then you cost that out. And it is a very high level cost analysis because you haven't got into fully designing the plant. The next step is to identify and develop lesser degrading alternatives. And again, those are concept level designs. And so you look at these lesser degrading alternatives that are practicable, and a range of practicable alternatives that would prevent or lessen degradation. Okay, told you, gonna come up with a detour on practicability. So practicable is a term that's used in federal regulations a lot, and in the anti-degradation rule, it was even specifically defined in the rule as to what practicable meant solely for the anti-degradation rule, okay? And it basically says that alternative is technologically possible. Somebody's actually come up with a technological process that would improve the quality of water. It's able to be put into practice. Somebody's actually built it to scale, say, and that it's economically viable. Again, ask 100 people, how many different answers do you get on what's economically viable? That's why states had really wanted to use the term cost effective instead of economically viable, because cost effective is a term that's used a lot in the industry, lost out. But again, these essays that EPA put out in response to comment said that economically viable could be interpreted as cost effective. So in terms of cost effectiveness, I'm going to give you my idea of what it is. Let's say down here, this scale is what percent of additional money would you put in to go above the base case cost? So the base case is kind of here at 0%. And then how much water quality improvement do you get for adding that additional cost? Well, up to 20% additional cost, you're going to get a 20% improvement in water quality. Okay, so you kind of cost effective, everything below that. But when you get above that, say up here to 40%, and you're only getting a 25% improvement in water quality, you have to ask yourself if that's really cost effective. You're putting, more effort into getting it out than what you are in terms of benefit. And so with that, there's really a diminishing return in water quality improvement when the cost is above 20%. So that's how I would look at cost effectiveness on some of these proposals. Then we say we identify a range of alternatives that'll prevent or lessen degradation. Prevention usually means no discharge. That can be hard in some places in the western part of Kansas and west, probably to the other side of the Rockies. You do have climate where evaporation exceeds rainfall and the amount of wastewater you can put in, and you might just be able to evaporate it. There can be irrigation or reuse of the wastewater potentially, but that's got a lot of issues too. And particularly if you're near a large city, how far do you got to get away to irrigate all that water? How much storage do you have to have for it during freezing weather, during times when fields are being harvested or planted? There's a lot of challenges there. It sounds real easy, but it's not. And sometimes they're technologically not possible, but quite often they're just too expensive to go with a total no discharge. And so then you look at lesser degrading alternatives, and that's up to the anti-deg author to select. And lesser degrading, again, was this compromise. The initial rule called for least degrading. And in my opinion, there's almost something that's practicable that can improve water quality. There are cases where it may not be, the cost just may be too much, but I think a lot of times you can find those practicable things that can improve water quality. And so if you go something that's like wildly expensive, you say, oh, I'm going to put reverse osmosis on, and wow, that's too expensive. So there's just nothing we can do. Expect the regulator to come back and say, hey, did you think of this or this or this? There may be things that you can do. So be truthful kind of in how you go about approaching that. There have been some things that states have tried to make this easier that have been turned down. Some of them kind of arbitrarily tried to define economic viability as, 1.x, 1.1 or 10% above the base case is not economically viable. And Iowa did that and said 115 of the base case is exceeded, it's not viable, and that was disapproved. How do you know? You really got to show it. Maybe you don't want anybody spending that much more, but you need to at least show that there are possibilities. So some states said, well, we'll get around that by saying, is it viable if it's less than 120% of the base case? We just won't say what happens if it's over. We'll imply that you don't have to do anything. Well, then comes up the question, begs the question of what if it's 121% of the base case and you get 70% improvement in water quality? What are you going to do then? You'd probably ask them to do it. So the percent threshold concept, I think, came out of an incorrect inference from EPA. Region 8 put out a really good guidance in 1993 where they did an excellent job of really explaining anti-deg, I thought. And they set up this non-binding rule of thumb that said, if anything is 10%, only 10% above that base case, we'll just consider it reasonable. And that's just like saying, it's just 10% more, we'll do it. And so what, you can see then what some of the states kind of did was turn that around, and they tried to say, well, it's exclusive, that if it's more than 10 or more than 15, then you don't have to do it. And that's never what that guidance said. So those have all been wiped out, and I think you might as well plan on just costing out some good alternatives. There's also a problem with that percent above or below. Engineering estimates, if you look at, there's groups that do estimating stuff. They have very legitimate documents out that say you can legitimately add 30 to 100% contingency cost for a concept screening level, which is what we're doing here, a very high screening level. So they call a level 5. And so could you game the system? Yeah, well, I'm not saying you would, but you certainly could. You might say, well, it's only 20% more, but this says I could throw 100% contingency on it too. Now I'm 120% more, so I don't got to do anything. So the goal used to be kind of rejecting all of the alternatives and just let you build what you want to build. Now with the way the rule is, I say you should look for truly viable alternatives and do a very fair cost estimate. And if one of those is less degrading and you can afford to do it, then you should choose it. So we're going to merge back out of this practicability here and kind of identify these practical alternatives. They say be creative. There's lots of things you can do. I worked with the state of Kansas and a community here recently that had phosphorus, and they, we compromised on them adding a filter. They weren't going to add a filter. They were just going to do biological phosphorus removal. Filter kind of give them belt and suspenders and ought to do a better job. So those kinds of things, just be creative as you think about alternatives. You cost those out and you look at present value of the capital and O&M, and I'd really encourage you to look hard at that, or have the consultant, whoever's doing this, look hard at it, because somebody could propose, say, for this phosphorus again, that you're going to add a bunch of chemical to it, and that's very low capital cost, but a very high O&M cost on the back end. So as you're going through all of those and trying to figure them out, get a little bit of idea as to what your long-term cost is on those. You look at the degree of degradation of each one, and if a lesser degrading practicable alternative has reasonable additional costs, it's the Nike principle. I think you just do it. And if there is no practical alternative, you can recommend the base case, but you need to think kind of long and hard about how you're going to justify that to the public. And if it's based solely on cost, then you're going to get into EPA probably is economic guidance on why that would be too expensive. Then the next step after all of that is remember to submit the anti-deg analysis to the regulator. If you've been working with them, getting the pollutants of concern and what your approach is to what makes it important. If you've done all that work up front, there shouldn't be any surprises. Nobody likes surprises at the end. So hopefully there wouldn't be much there to modify, and then the regulator, as I said before, will put the anti-deg analysis and the draft permit on public notice, and they'll propose limits that the anti-deg analysis came up with, and public has the opportunity to comment. And then, what typically happens, the permit gets issued as proposed, or maybe there's a slight modification in a permit limit, and you move ahead with design and construction. very rarely do those permits get denied. So I think you just need to do a good job with your Antideg, work with your regulator up front, and you'll get there. So if I put it a real simplified summary here at the end is, what is anti-degradation? The goal is just to keep high quality waters as high a quality as practicable. And I use the term practicable. How about that? And if you're proposing, though, a new or important or expanded discharge, look at the alternative treatment schemes. If you can get one that lessens degradation in that high quality water and it's practicable, go ahead and build it. If there aren't practical alternatives, again, you got to be able to justify that, and you need to make sure that the discharge to that water stays where it's at, that you don't lower quality any lower than the water quality criteria. So I say, even in Kansas, pretty flat. I think we got some pretty waters in places. And so I say, you need to use anti-degradation as a tool to improve water quality. I assume that's why most people got into the business. And like I say, its intentions are good. And with that, I can take any comments and share with you my cartoon that shows that sometimes water quality for designated uses is in the eye of the beholder. So with that, Owen, we got any questions?
Awesome. Yeah, we did have a couple roll in. Someone was wondering where they could find the list of water body tiers.
For a particular state, you would have to look for in that state. And like I say, I'm only aware of a couple. Oklahoma's one, and I'm kind of forgetting the other one right now. But you're not going to find it for most states. They're going to be using that pollutant by pollutant analysis.
Gotcha. So someone was wondering on the topic of probable permit limits. They were wondering if you're familiar with whether there are states that have a process for providing draft permit limits. They've run into an issue in their own state with that.
Yeah, I am. In Kansas, where I was from, it's done all the time. I know there's some states who will put out construction permits before they do operating permits for NPDES. And to be able to do that construction, they have to give you some idea on what the limits might be. So yeah, it's out there, and I think you may just have to press the agency. You got to tell them what you're doing, that you are proposing a new or expanded discharge, and you need to know where to start from on the anti-deg analysis, and hopefully they can work with you on that.
Okay, so then on the topic of economic viability, they were wondering if you're able to comment on why anti-degradation has a different process to assess cost than WQS variances.
Well, it's it's addressed in EPA's economic guidance document from 1995. And it specifically addresses, it calls out anti-degradation. And, and if you remember that statement I made at first that came out of that guidance document, they don't look at it as trying to limit growth. They just want to make sure that alternatives are looked at differently. And so it makes it probably a little less rigorous than if you're going for a variance.
Okay, awesome. We had two more questions roll in. Someone was wondering how many states assign limits based on treatment capability, if you know.
Oof. I can't tell you. That's a fear that everybody has, that if I treat real well, they'll drop the limits down and make me, treat to that better that I've done. I haven't seen it happen very often in the states I've worked with, which are mainly here in the center of the country. The fear is always thrown out there, but I haven't seen it put into play. I'm sure somebody's probably tried it somewhere, but it's not something I've routinely seen happen.
Okay, fantastic. And the final question we had come in was, are mixing zones often considered a potential practicable option?
Oh, that is an excellent question. Um, yeah, I suppose it could be on that, but you could also look and the state may look and say that they want, okay, if we got a mixing zone, if people know what that is, that says that you can mix in so much of a river or a water body, say 25% of it, and by the time you get to the end of that mixing zone, you'll have achieved that. There are states who look at it as even at the end of that mixing zone, they want to see that it is not increased, that it is not degraded any further than it has to be. So I think you'll see many, many states who will not allow that as a practical alternative. They'll just look at it as you should not degrade at the end of the mixing zone.
Okay, fantastic. I think that's about it. So a huge thank you to Mike today for sharing his expertise with us. Following this webinar, you will receive a follow-up email with the slides from today and a link to the recording. We also ask that you complete the webinar evaluation following the webinar so you can let us know your thoughts on today's session, as it helps us plan for future webinars on topics that are important to you. Thank you again, and we hope to see you at future ESCN events.